Okay, so Sondek, are you able to see these slides? Oh, Nimthrin, can you see this?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
Slides and the basic types of effects controller.
Thomas.
sir.
Okay, so this we have studied emo and you have done this one, I think. Shunt controller and have you
Yes,
done
sir.
this one?
Yes, sir. Yes, sir.
Bila, sir.
Compound.
This one you have done, no? So this also done.
Combined.
Okay, till where we have done combined. This one also done, no? This one done. This one? So this is actually combined series. Here you are having is. So in this case, what you are having is series. So there are two series and effects devices, which is actually linked through this DC power organ. So this one. So this is linking these two. Okay, so this is then and then giving to the. So even if one fails, the other is still going to do. So it's like a parallel operation of the series effects devices. Then it can be combination of this one separate. This one you are having, just you can go through it, or it can be unified controller as shown in figure 3.9. So that we have seen. So you can just see this one. This is a unified one from one bus, then you're directing to the other one. So here now the problem you can see is, in this case what you are having, the rail power transfer capability of UPFC can be like both rail as well as the reactive power. So it can be, what you will do is you will be able to, by using this you will be able to maximize this. Okay, so we will be able to, so you are having is this part. So this, so by using this one you can maximize this. Okay, so this is what you can have. So you can see, so you can go to the rail power transfer capability of unified series controller, which is actually commonly referred to as IPFC. So it makes it possible. So first thing is, it makes it possible to balance the both reactive power and active power in the lines. By then what it is doing is, the advantage of balancing this is it will maximize the utilization of the transmission system. Okay, so this is what you have. So series nadi. So the main objective of our anidi, that how to optimize it, how to optimize the use of this transmission line bandwidth again. That is what you will have. So here up to that Gara, so we will be using like either series compensation or shunt compensation in order to make it more optimum and transmission line bandwidth. So okay, so this is what actually the fax devices are meant for. So unified DC terminal of converter are connected together. So another thing you have is, so it is connected together for rail power transfer. Okay, so that is what you can see. Then combined series shunt nadi can be combination of shunt, separate shunt, or can be coordinated manner. So this is your separate shunt and series. So this part is, so this is your series one. Then it's combined, connected separately to the shunt one. So this is the, okay, so this. And then in a coordinated manner, so it is coordinated. Okay, so coordination is there between these two. This is what you, or it can be a unified power flow controller. So this is another fax devices which is actually used in the transmission system for the allocation of this power optimization and the active the reactive power. So this is there. So this is your unified power. So in under unified power, now what you are doing is, so here in case of the coordinated one, that coordination was there here. So this coordination part is not there now. This coordination, so coordination was there in case of this, right now. So this you can see coordination, no? But in this case UPFC nadi, this coordination part is missing. So if you go back to this figure, this coordinated control, so controlling part is not there, whereas in a unified power flow, this coordinated controller is not there. Okay, so the only difference is the coordinated controller is not present in this UPFC. Okay, so in this case, what is happening is when shunt and series are unified, there can be a real power exchange between the series and shunt controller via this power link. So the real power can be exchanged through this link. Whereas in case of the normal one, the coordinated one, the real power may not be able to exchange because of the fact of that controlling part is there here. So and coordinated control is here. Okay, so this is what you can keep in mind. Okay, unified. So this is like, and just for this, so you are having unified controller for multiple lines. So you are having is multiple lines. So line 1, line 2, line 3. So many lines are controlled through this. So you can connect this one. And this is again with storage. So you are having storage here. So storage can be, you will have different storage. Guys, storage, anyone? Hello. Namit. Hello.
RAM EULA, sir. ROM.
Okay.
RAM,
Roshan.
ROM, ROM,
Kachi and bed storage.
Computer EULA, sir.
Ah,
Computer na RAM, ROM.
man. This is Magi then computer level, not at computer level, power level, storage, battery storage, so power level, not at that chips level. So we are having is like the battery bank can store the energy. The super magnetic and the magnetic materials, the superconducting magnetic, the flywheel done. So these are some of the storage devices commonly used in this. Okay, so this is another one. So this is UPFC with storage. Okay, so this is your UPFC for multiple lines. Okay, so otherwise, if you have that another one, if you want that the coordinated one, so you can have your coordinated control here. Okay, so this you can have CC here, so coordinated control dynamic. So now you'll see the definitions of fixed controller. So just before going to, like, we have converters are usually classified as voltage source converter and then current source converter. So this is your voltage source and this is your current source. So you can see here. So the voltage source is shown in figure, this one. So this is your voltage source converter, VSC. Okay, so please. And then this is what it is written is, it is represented in symbolic form by box with a gate turn. So this is your VSC actually, total VSC. And supply to VSC is given by this capacitor. Okay, so this is your supply. So this is what it, so formed by box with a gate turn of device parallel by reverse diode. So this is this one. Okay, so this, and then DC capacitor as its voltage source. So this DC capacitor as its voltage source. This is your. Then similarly, current source converter is shown in this case. This is your current source converter. Okay, so current source, so this is your so current source nadi, this is your current source and it's shown represented by box. So this by box cannot cover, so this is the case, and then in series with the diode. So this is diode, this is your fax device, and current DC reactor is current source. So this is your DC reactor, and this is your actually storage dani. So with interface dani, that is what it is. And voltage source, the current source, that is what you have. Okay, so this is your voltage source. Iga, any questions, any doubt here? So storage the any large DC capacitor, ESS, the SMES. Later on we will have that things. Hello.
Godola, sir.
Huh?
We are understanding, sir.
Okay, so now the definitions. The first we'll go with the shunt connected controllers. So on the STATCOM that is there. So just definition you can go through. Okay, so there is nothing to explain. So you can just go through STATCOM. So later on the detailed working principle construction and everything will be we'll do later on Gara detail video. Right now we'll just see this. Then SSG we have. Okay, so the figure you can just go. So BESC that is a chemical based storage system using shunt connected voltage source. Battery energy storage system. Okay, then superconducting magnetic energy storage system. So that is your battery. The static wire compensator also is there. Okay, so this is what we will have. So SVG, SVG. Later on, we will be using all this thing to compensate the reactive and active power flow in the power system transmission line. The thyristor control reactor. Again, another definition, another. So detailed working principle, all this thing you will see later on. So that is series Nadi. Now we are having again under series connected controller Nadi. So these are the two things we are having. So it is connected in series with the line. Okay, so current source. Again, another one is IPFC, the thyristor control series capacitor. These are the two things. So later on we will come. Okay, so this is your case. UPFC. All this thing will come in detail later on. Okay, so like use this one, so you can just refer these books wherever possible. Okay, so Hanimchi, Jamchi, so any doubt, anything you have? Hello.
Mindula, sir, Datodi.
No, sir.
So otherwise, can we do this? Correlation being all.
Yela, sir.
Yes,
Yellow,
sir.
sir. Shim Nazira
Yes, sir.
Dekula.
Leshmberela, sir.
Karibina that BC can it was quite relation this and network this.
That is Dharmism, sir.
Let's see the animal. Otherwise, any the feedback as to any feedback, anything.
Juba college na look po ko sir.
College na didan nga si laro na di.
Nadi, sir. Pesara tama sibula.
Chimna boarding
Now
time.
now college na di kadi mo dida. So
Che logo ko
hopefully,
nahi.
April month the possibility is very less.
Semester delay sir.
La.
Semester delay next year continue.
Ani mere milino mina. Tato vacation day navadan winter vacation this madhya be watching so sunyo probably. Ugin wants to keep no.
Yes, sir.
Khunle pe thiyo.
Gawa inga.
Sir, equal network Dharmism, sir.
Khui kha 2G.
Yes, sir.
That's time 11 to login base, that's time to Zoom.
But UP juga UP Ugin Punso is not there, no?
Yes, sir. Yes, sir.
Also came.
Gimana ya, sir?
Net nan
Network
mula,
issue
sir.
dulu.
Amjana came.
Yes, sir. I'm this.
Oh, no, sir.
Yes,
Yes, sir.
There, okay.
Yes, sir.
मैले
Kilo
4G
angsu,
चाहिँ
Nan mula, sir.
kilo angsu,
2G sir.
Kiloang Mindula, sir.
kilo 3,
Let's say ay nabe मैं करना क्या हुआ sir?
okay, dile ani, seong rinzin,
Sorry,
Network meeting will have, sir.
2G
High
में sir.
level namaz mela, sir.
la,
Network problem do
Network
love, sir. Changrizina.
okay, to. So, 2 years any memo. So if you have any doubt on this, you can just keep Anina. Share
Yes,
page.
sir.
You can share it.
Yes, sir.
I will upload the slides on this thing.
Okay, sir.
Tup, sir.
Otherwise, everything is fine, no?
Yes, sir.
Yes, sir. Fine, sir.